Can you guys see those slides?
Yes, we have them in not the sort of full screen view, but just with the thing on the side.
Is that readable enough? Is the text sort of large enough?
Yes, yeah. I think that
Okay, I'll leave it like that because I don't think I have a better PDF slide viewer on Linux. Sorry. Okay, so I actually changed the title to just cost functions for predicting TB outpatient visit costs, only because I'm speaking a little bit more generally than just about econometric cost functions. So we'll get into that in a minute. But to sort of frame the issue, I'm sure everyone's familiar with this scenario. You need a TB unit cost for cost effectiveness analysis, economic evaluation, investment cases, all sorts of things that TB data gets used for. And often there is little or no usable, sometimes costing data for the particular countries you might be modeling. So there's a drive to improving the availability and quality of unit costs for these contexts. So where do the TB unit costs usually come from? They're generally taken from secondary literature, published or grey literature, where unit costs don't exist for a country. They're often borrowed from a similar country, and they typically published unit costs derive from a very small number of sites, especially in LMIC. 10 is actually a sort of a reasonably large sample size comparatively when you actually look at the literature on TB costing studies. And then you take a unit cost, it'll be adjusted for currency and inflation to the current year and currency. But that's pretty much it as far as adjustments go. And this is despite the fact that we know that unit costs vary quite a bit across settings and contexts. So they vary with the scale of the intervention, the scope, so what other services are offered by the facilities that are also doing TB services, local input prices, of course, types of facilities, efficiency, and things like that. So my work has been looking at the question really of how to best extrapolate unit costs from secondary data. And to do that, I've been using a data set that probably a lot of people are familiar with, which is the Value TB costing database. Just to go over what this contains, this is a micro-costed database from 5 different countries using a comprehensive, the WHO costing methodologies. It's across 5 countries: Ethiopia, Kenya, India, Philippines, and Georgia. There are 115 facilities in the data set with 500 observations. And today, as a case study, I'm looking at TB outpatient visits. There are other TB intervention types, service types in the database, but outpatient visits are the most numerous. So that's the data I've been focusing on. And costs are broken down into individual cost components. So these are grouped into fixed costs, which are things like capital expenditure, like buildings and equipment and things like that happen at the facility level, and variable costs, so things like drugs and consumables that recur with each unit of service and are pretty standard regardless of the facility. So approaches for deriving unit costs from secondary data. These typically break down into 3 approaches. So on the one hand, you could just take a unit cost from a study, make adjustments for currency and inflation, but it's not decomposed any further or adjusted any further. So, it's like a sample mean, basically. And then you just multiply that by the volume of services in your modeling exercise to get the total cost. And then propose improvements over this, because obviously taking a unit cost, assuming that it's constant across different levels of scale, is a pretty strong assumption. So proposed improvements are to use cost functions. So these basically break down into accounting, or sometimes called mechanistic cost functions, where the cost is decomposed into cost components, at the very least into fixed and variable costs. So then the total unit cost is composed of these 2 elements. Fixed costs. This allows you to sort of model fixed costs as varying with the volume of services offered. So the fixed costs at the facility level don't depend on the number of services offered. So the average cost per service actually decreases as the number of services increases. And then the variable costs, like I said, are things like drugs and consumables that don't depend on the scale of the intervention offered. It's the same price per visit, regardless. And then finally, we have econometric cost functions, which are also sometimes called empirical cost functions, where you try and estimate the unit cost statistically given arbitrary characteristics that are relevant to the cost. So this is an example of an econometric cost function. It doesn't have to be a log normal function, but because costs are typically right skewed, commonly you would use a log normal or maybe a gamma function and do some kind of regression analysis, basically. Okay, so when we're comparing these cost function approaches, econometric cost functions obviously require a sufficient amount of multi-site cost data that is rich in covariates to train the model in the first place. And then also they require those covariates to be available at the point of use. So they've been perhaps underused for these two reasons. And mechanistic cost functions have been proposed as more feasible to use than econometric ones, partly because the data requirements are at least nominally less. So you can populate the fixed and the variable costs from small scale cost studies, basically. You're not trying to learn from a large amount of data, and you just need data on volumes to do this fixed cost adjustment. Just to drill down a little bit more into fixed versus variable costs and how you would populate a mechanistic cost function. So variable costs, so decomposing a unit cost into fixed and variable costs is, it's not just that you can adjust the fixed cost for scale, it also break it down into these components might make it easier to get accurate adjustments for different contexts. So for example, for drugs and supplies, there are typically international or national price lists. So we could get up-to-date information for those particular components of the cost. Clinical staff time, which is usually a variable cost, a little less easy, obviously, but you can get sort of data on national doctor wages, for example, and then there'll be some normative amount of time that a clinician spends with a patient, depending on the type of visit. So that might vary a bit across facilities, but not hugely. Fixed costs, on the other hand, are going to vary hugely across contexts, right? Because they comprise things like buildings, support staff, maintenance, utilities, equipment, overheads. Different facilities of different scale. A larger facility is going to have much higher fixed costs. Local prices are going to feed into lots of these elements. The scope of the facility is going to matter. How many different services is it offering? And also these are less readily observable. So it's relatively straight. You could go into a facility and you could follow a clinician and you could see, okay, when they do a TB outpatient visit, this many supplies are used, this how much time is spent with the patient, and these are the drugs required. And, you can estimate your variable cost quite straightforwardly, but you can't really just go in and say, oh, okay, well, the average building cost of a single visit is X. It's just not directly observable. You need a lot more information and some method of allocating capital costs across patients. And overheads seem to be particularly tricky to measure, which is evidenced by the fact that they're often missing when you look at TB costing studies. So, and just to emphasize this point about overheads, in the value TB data, overheads are a really large percentage of total visit costs. So if you look at the average cost of a visit in each country in value TB, the percentage of that cost that was attributable to overheads varies from at least a third to over half of the total cost. So just a word of caution, wherever you're getting your unit cost from, do look out for this, because the 2020 literature review, only 30% of costing studies included overheads. So that's just something to look out for, regardless of where you get your unit cost from. So I'm going to focus on populating the fixed cost, because as I've said, I think it is quite feasible to populate variable costs from drug lists and things like that. But fixed costs are the really tricky part. So a few different approaches that you could use if you were to populate your fixed cost from the secondary data. The first one would be quite simple, quite similar to just the simple unit cost approach. So you could just take the average fixed cost per visit in the data set and use that as a predictor of the fixed cost per visit in a new setting. This is effectively assuming that there's no economies of scale. So the fixed cost per visit is roughly the same across different facilities. And if I just look at the average fixed cost per visit, that's a good predictor of the fixed cost per visit in some new setting. At the other end of the scale, you could, rather than looking at the average fixed cost per visit, you look at the average total facility fixed cost in the data set, and then you adjust that for the known scale in your new setting. So QI here is scale, volume of services provided. This is making a very strong assumption in the opposite direction, right? This is assuming a very, very strong economy of scale. It's assuming that total facility fixed costs are sort of homogeneous or drawn from the same distribution across all different facilities. And just in some facilities, they're distributed across more services, and in some facilities, they're distributed across fewer services. So the fixed cost per visit then is going to vary very strongly with facility size. But hopefully you can see that this is, a very strong assumption, because obviously volume and total facility fixed costs are not going to be uncorrelated, right? Like larger facilities are going to have higher fixed costs typically, and they're also going to be administering more visits. But I wanted to include this because of the sort of theoretical link to the way fixed costs are typically thought about in a mechanistic cost function. And then finally, I mean, what we're really after is the predicted fixed cost of a visit in a facility, conditional on the specifics of that facility, right? So some arbitrary function of facility characteristics, which might include scale and might include other features as well. But then now we're back at the empirical or the econometric approach, right? So I wanted to see whether this could be done using the value TB data in a way that's sensitive to those concerns about econometric cost functions, which is the availability of data and particularly the availability of the covariates when you come to actually use the model. So I've compared these three approaches, and for this one, I'll say a little bit more about how I specified the regression model that I've used for F here. So I am using a log normal model, and the mean predictor is a linear combination of fixed effects at the facility level and country random effects. And in choosing the covariates, so I started from theoretical cost drivers, previous cost function literature, and I refined the covariates, according to which were the best predictors. And this gave me a list of this top one model with best fit. So facility type, so that's like the level of the facility. Is it a primary hospital, secondary hospital, health center, lower than health center? Is it publicly or privately owned? Where is it situated, urban or rural? The outpatient volume, and then a measure of efficiency as well, which is the number of visits per staff member per day. A local price indicator, which is local building prices, and then country random effects. But then I wanted to refine this further based on which covariates would actually be available through standard reporting. And I thought that, so staffing levels, generally not really available. Number of TB visits. So number of TB visits, although total outpatient volume is standardly available, TB visits might not be. So this efficiency measure had to go, and there wasn't really a good alternative to that. Local building prices, I think as well, would be pretty tricky to come by. So I've just taken those two variables out of the model, and then the restricted model is just all these very standardly available covariates. So facility type, ownership, urbanicity, outpatient volume, and then the country random effects. Just to show you briefly The in-sample fit of these two models, as you'd expect, the model with more variables fits a little better, has smaller confidence intervals on the left, predictive intervals, sorry. But then the purpose of this work is really to look at how well these approaches help us to extrapolate to new settings. So the much more important measure here was looking at out-of-sample fit. So for that, I used k-fold, 10-fold cross-validation. So leaving some data out of the training set, training the model, and then predicting on the left-out data. And when you do that, the predictions for sites not in the training data look a bit more like this. So you can see, again, model 1 does pretty well, model 2 a little less well. And then the comparators, if you recall, were just using the average fixed cost of a visit in the whole data set as a predictor, and then also using the average total facility cost divided by the volume. And I used the same out-of-sample approach for those. So I calculated the sample means on 9 of the 10 folds of data, and then use them to predict site costs in the left out sites, if that makes sense. And yeah, this is how those predictions look. So the average unit cost, the simple unit cost approach on the right, it's not so bad. The scale adjusted approach on the left that assumes these really strong economies of scale and sort of no difference in total facility fixed costs, obviously gets things quite wrong or quite all over the place. Very large margins of error. And just to quantify those, here's a numeric comparison of performance of these methods. So the full model obviously does best. The restricted model does all right. Then the unit cost, the average unit cost approach, in terms of absolute error, so this is mean absolute error in the first column. So then taking just the average unit cost, when I say unit cost, this is the fixed cost per visit. It's not so different from the restricted model, although when you look at root mean squared error, it's a little worse. So that means there are some larger outliers here. And if you look at the scale adjusted unit cost does very poorly. You can see very, very large errors. So the truth is somewhere in the middle, basically. There are economies of scale. So the model that includes scale and other covariates does do better than just looking at the average, but not nearly as strong as the scale adjusted comparator assumes. And then I think it's worth noting that the models do offer improved accuracy, but really also much narrower and better calibrated uncertainty. So if you look at actually all of the predictive interval coverage is sort of reasonable for all of them. It should be around 95%, right? If these are nominally 95% predictive intervals. So pretty good for the average approaches. But the median width of those predictive intervals is much higher for the national average approach than for either of the model approaches. And this figure on the column on the right is, so relative to the mean prediction, what is the width of the predictive interval? You can see that for the full model, it's about 2.5 times the mean. For the restricted model, about 3 times. And then for look at the national average unit cost is about 4 times the mean. So yeah, so you get better calibrated uncertainty, basically. Okay, so this is looking at performance in single sites, which is, I think, a bit less useful because what's typically needed is a unit cost at the country level, right? Like the national average cost of a visit. So for doing that, I've predicted the cost in every facility and aggregated them using a volume weighted mean. So a facility that offers 10,000 visits obviously contributes more to the average cost of a visit than a facility that only does 10 visits a year. And these are the results for the full model and the restricted model. So again, the question is, can these models extrapolate to new settings? So I wanted to see, could they predict costs in entirely new countries that weren't used in their training data? So for this, I trained models on subsets of the countries, so only 4 out of the 5 value TB countries, and then use it to predict fixed costs, average fixed costs in the country that was excluded from training data. And you can see it's done very well in Ethiopia, Georgia, pretty well in India, Kenya. The only one that hasn't done so well is the restricted model in the Philippines. Obviously, the absolute errors here are also pretty small. This, if you look at the scale, much smaller than for single sites. But yeah, the Philippines hasn't quite got the true value in its predictive interval. I think this is because the Philippines, most visits are offered in community health units, which are a below health center level, health system level. And there weren't really many other facilities at that level in the rest of the data set. So when you leave the Philippines out of the training data, it's not really able to very well learn the properties of those facility types. And then most of the visits in the Philippines are in those facility types. So it gets it a bit wrong. So I think that's something to bear in mind when using these models, that if the primary difference, if you're trying to predict something in a new country, and you know that new country is different from the training data in terms of the composition of facilities that visits are delivered in, a higher rate of public versus private delivery, or more primary hospitals, or what have you, that seems to work very well. But if there's sort of an entirely new facility type, or a facility type that isn't well represented in the training data, that would be a reason to be cautious about using the models, basically. And then for a comparator for this approach, I've looked at, so I mentioned that when country data is lacking, a common approach is to just use a similar country that you have data for, right? So I've compared the model performance in out of sample countries to just taking a donor country from the same data. So picking the most similar country from among the value TB countries, and using the average fixed cost of a visit in that country as a predictor of the average fixed cost in my country of interest. And I match these up as similar countries based on various characteristics. So GDP, structure of the health systems, structure of the TB program, geography. And this is the mapping that I came up with. So for Ethiopia, I chose Kenya as the most similar. Georgia didn't really have a good candidate donor from among the other 4 countries. It's just kind of different. So I did choose the Philippines based on similarity of the health system structure and TB program structure. But yeah, I sort of knew when I was choosing this that this wasn't a great candidate. India, I chose the Philippines. Kenya, I chose Ethiopia. And the Philippines, I chose India. And then I created predictive intervals for these predictions from a combination of sampling uncertainty around the estimate, the donor country estimate, and then also some uncertainty around how well it would generalize to the new setting. And comparing this to the model predictions, this is what we get. So you can see that actually using a donor country works reasonably well in most cases, or quite similarly well to the models. I think it's a little less accurate than the models, but barely, especially in the Philippines and Kenya. It's basically comparable to Model 2. The only place it didn't work well was in Georgia, which I kind of knew up front that, there wasn't really a good candidate for Georgia. And yeah, indeed, the Philippines was not a good candidate, not a good match for Georgia. And I think it's quite interesting, the contrast here, because the model was very well able to recapture the average cost in Georgia, even though there wasn't a good suitable donor country in the data set. So that was quite encouraging, actually, that, the models can extrapolate well to new settings, where, even where the training data is different. But I think, again, this comes back to the fact that the training data is different in composition, but not so different in cost drivers. So all of the facilities in Georgia, the types of facility and the costs and the features that drive the costs were well represented in the rest of the data set. So yeah, the sort of summing that up, I think the econometric approach is most valuable when no appropriate donor country is available. And the training data has to contain enough information to identify the coefficients. So it can extrapolate well to new countries that just have a new mix of previously observed characteristics, but not when the new country involves entirely new facility types. Oh yeah, so then I wanted to compare this, as well as comparing to the donor country approach, I also wanted to compare this to using local data for the relevant country, but small samples, because this is often, so I think that it's often more palatable perhaps to policymakers to use local data rather than a model that's trained on multiple countries, possibly not including the country of interest. But local data, I mean, we're typically talking about sort of, 3 sites, 5 sites, 10 sites would be good, right? So I wanted to have a look at sort of what does it look like when you use these small samples from local data. And to do that, because we only had about 30 facilities per country in the data set, I used bootstrapping to inflate this to a national sort of scale. So sampling 3,000 facilities from the 30 facilities we had, and adding just a small amount of random noise to create, sort of national populations for each of the country. And then I simulated surveys from each country of different sizes. So of 3 sites and of 10 sites. I calculated the average fixed cost of a visit in each of these synthetic populations, and also the average fixed cost of a visit in the sample, so the sample mean estimator of this. And I used the survey package in R to create confidence intervals using the standard, the most standard way of constructing confidence intervals for a ratio estimator, because the volume weighted mean is a ratio estimator. And visualizing the results, this is what it looks like. This is the first 100 surveys visualized out of 1,000, just to give you an idea of how what the spread of results looks like. So I've colored, I should have drawn this on top, you can't see very well, but there's a black dashed line on each of these figures, which represents the true average cost in each country. And then I've colored in blue the confidence intervals that contain the true value in them, and in red confidence intervals that do not contain the true value in them. And you can see quite a bit of red, especially in the 3 site case, but also in the 10 site case. And you can also get an idea of how variable these estimates are, right? They bounce around a lot, and there are some really wide confidence intervals, some really tiny ones. And they vary around the true mean. And just to quantify this issue with coverage of the true mean. So the problem with small samples is obviously not only that the mean estimate is high variance, but nominal 95% confidence intervals are very poorly calibrated in small samples. And this is like a standard issue in statistics. And in this case, in the data set, you can see that when you're using 3 site samples, you have very poor coverage of the true value. So this is supposed to be 95% confidence intervals, but actually the true value is only in there in sort of half or around half of the time in most countries. And even when you're using 10 sites, okay, we get up to like 70% coverage, but that's still not great, right? So this is a real risk for decision making, because it's not just that your mean estimate might be off, but you can't even really you can't make precise how risky it is to use this estimate, because your uncertainty is totally miscalibrated as well. So it might look like you might have a really narrow confidence interval, and it might look like you're making a decision with quite high certainty, and actually the true value is quite likely to not even be in that confidence interval. So it is a problem, I think, for evidence-based decision making, that these confidence intervals are so poorly calibrated. Okay, so if you want to use these models and play around with them, there are 2 ways of doing so. So I've got an R package and a web app. I'll just open up the R package if I can. There's no link. Let's see if I can share my... Let me just open it up and see if I can share my tab instead, so I can just show you the R package and the... Okay, can you guys see that?
Yep, that's coming through.
Okay, great. So yeah, this is the documentation for the R package, which is available online. Well, actually, do you know what? Let's do the web app first. So this is the web app, and I haven't really talked about this today, but I do also have an econometric model for predicting the full unit cost of a visit. So I do think that it is optimal if you can break it down into variable and fixed costs and get the variable costs from price lists and sort of local wage data. I think that's probably optimal. But if for any reason you'd rather just predict the entire unit cost, that there's also a model available for that. And you can see I've got a toggle here. Yeah, sorry, go on.
Just sharing the, I think this is just showing the GitHub still. There we go, yeah.
There we go. Okay, sorry. Yeah, so here I've got, you can see the two buttons correspond to whether you want to predict the full unit cost or the fixed unit cost. And then you can also include those additional covariates if you have them. So the efficiency and the local price covariate are if you have them. For predicting the total unit cost, you also have visit type in there. This in the value TB data, the fixed cost didn't really vary by type, so the fixed cost model doesn't include type. But yeah, so if I predict that for a single setting, it gives you a full distribution of the predicted cost there, with a 95% credible interval for that cost. Or you can also change the confidence interval. So that's one way to use for a single setting to use either the fixed cost model or indeed predict the total unit cost. And then the R package is so the R package is a little more flexible. Obviously, you can if you're predicting for lots of facilities and aggregating to the national level, then it will be easier to use the R package, and there's a lot more details about the models in here, basically in the documentation if you're interested. It also shows how the models were fit. There's also details on how you could fit new models to the same data. You could change the priors. The priors that I'm using are all very weakly informative. But yeah, you can change the priors if you like. You could fit to different covariates. You could play around with that if you were so inclined. All right, I'll stop sharing that and I'll just go back to my slides. So just to mention some limitations of this, obviously this is just evidence for one type of TB outpatient service. How well these results would extrapolate to other services is not a surefire thing. Obviously, using the econometric models requires you to know something about the national distribution of facility types. I have tried to make sure that the variables are things that could easily be come by, but it's still a little more cumbersome than obviously just using a sample mean. For the country, the extrapolation to new countries, the leave one country out analysis, with only 5 countries in the data set, obviously this is also kind of limited, right? So I've only been able to test how well the models generalize for those 5 countries. So I think the results are encouraging that the models will generalize to other countries with the caveats that I mentioned. But yeah, I obviously only had 5 countries, so what can you do? And finally, just to mention, yeah, even though these are referred to, these statistical models are referred to as econometric cost functions, they're obviously not econometric in the usual sense of doing causal inference. So I'm not trying to say that the fitted coefficients should be considered the true unbiased effect of these different cost drivers. I mean, sort of by design, the second model has omitted variable bias at the very least, right? So really it was about optimizing their predictive performance using the out of sample fit analysis, and not trying to estimate the true effect of different cost drivers on unit costs. Okay, I'm going to stop there. I can share these slides. There's a couple of references at the end also. But yeah, it would be great to hear people's thoughts, questions, feedback. I'm preparing a manuscript at the moment about this, so really, really helpful to know what people liked and didn't like or thought was missing.
Fantastic. Thank you so much, Alex. That was genuinely really, really interesting. As a non-health economist, I will let health economists, luckily I see we have a few on the call, ask questions. But Pete, do you want to go?
I hope you're not accusing me of being a health economist. Actually, but yeah, that was great. I really appreciated the effort you put into the background, because it made it a lot more accessible for people who aren't, in fact, proper health economists. But yeah, actually, I had three questions, which is maybe cheeky, but they're all relatively small, or at least two of them are. So one was, the like the fit plots you had with the kind of forest to vertical, with a couple of those, and also looking on the website. I had the sort of impression that the data is kind of tilted like that relative to the line of fit. And am I seeing things, or is there a reason why there's a kind of weighting towards some of the data rather than others?
It's just hard to predict data at the extremes. So there are some facilities that are weirdly cheap, and it's just very hard to see why they're so cheap. And there are some facilities that report weirdly high costs, and it's sort of just hard to see why they're so high, basically.
But it's systematic, right? So it's like random. You sort of under predict the low costs and over predict the high ones. So that's something you could correct for, no? If you
maybe. I mean, do you have any suggestions, like, for different? It depends. I mean, it could be that it could be a missing covariates thing, right? It could be if I add in some nonlinear terms, but then there's a balance, right, between keeping the models quite simple and doing that. Or it could be using a different functional form, but I did experiment with a few different functional forms, standard ones that you would use for sort of cost data, and the log normal was the best. So yeah, I don't know if there are any good ideas about those corrections. I'm very open to them, but I haven't really been able to pin down any major improvements.
Yeah, I won't try and make any off the top of my head. I'm not sure I have an easy win, but without knowing more about it. So the other two were, I vaguely recall at some point there was an interest in trying to use spatially structured models for some of these country level predictions for unit costs. I was just wondered if they'd been explored at all.
When you say spatially structured, you mean so neighboring facilities having similar costs, or what exactly?
Yeah. I mean, what I really meant, aerial statistics at a country or region level, but
aerial statistics. Well, I mean, that might give you an indication of facility size.
No. I mean in the spatial. So by that I mean as opposed to point space statistics. So you putting priors on spatial structure to try to mop up some of the unexplained variance from the explicit predictors. So in other words, there's greater weighting of close by countries, other things being
I
equal.
see. Yeah, close by. Yeah, I don't know that proximity of countries is such a strong indication of similarity in costs relative to some of the other explicit cost drivers. Yeah, I'm not sure that spatial proximity is such a great predictor of these types of costs, basically. Yeah.
And then the last one, I'm really sorry for the three.
Yeah.
It's sort of interested in the actual measurements that are being fitted to, and whether uncertainty in those is ever explicitly included, because
that's such a great question. Yeah. The short answer is no, basically. Uncertainty in the measurements is almost never included, and it's something that I'm quite interested in, because obviously I think that 100% is measurement error in these things. So yeah, that's something that I'm interested in looking at including, but yeah, as yet it's not, and I've not seen it done, basically.
Okay, great, thanks.
Yeah.
I'll shut up.
Thanks, Pete. Some interesting questions though. Alvaro.
Hi, Alex. Thank you for the talk. I also second what Pete said about the background. Very helpful for people that have a hard time getting into economics concepts and stuff. I was quite interested in this, and I have two questions. I guess one was kind of answered when you were showing this, the website app. But right now that you have this only treatment type, I guess if you were to try to use this for a different purpose, I guess the methodology that you suggested was just grab, for example, in my case, it's about an immunoactivity survey, just grab the price from the global pharmacy, I can't remember the name, plus maybe some consideration about time, plus the fixed cost that you're getting from that. Is that correct? Is that how?
What was the activity, sorry, that you're particularly interested in?
Application of a skin test for exposure to MTB.
Yeah. So if it's something that would happen in an outpatient clinic, that would be the recommended way of doing it. Yeah. For different outpatient visits that we had in the Valley TB set, like I said, so there's a full model that also has visit type in there, but it's modeled as a random effect, the visit type, and it may be slightly. It's fine, like it works okay, but I actually think it's better if you have more information about the activities that compose that visit. I think it would be better to do what you say and separate out the fixed costs from the specific costs that happen happen with that particular activity, like the clinical staff time, the supplies, etc.
But I guess the addition of this fixed cost that your model can estimate is about basically not underestimating a lot of the costs that we wouldn't be able to capture otherwise.
Exactly,
or
the overheads. Yeah, I actually in the R package also have a model that fits only overhead costs. So it depends also where it's administered, because so most of these TB, so in the Valley TB data, most of the outpatient visits happen in like dedicated TB clinics within larger facilities. So that would be something to consider. If that's the sort of setup you have, then I think it would make sense to use these models. But if you knew something more about, and the more you know about your particular case, obviously the better, the more detailed data you can get about it. But if you leave out fixed costs and you leave out overheads, you're going to be underestimating the cost, basically. Yeah.
That makes sense. And another question that is more about adding to your package is, I don't know a lot about this TB values study, but is there a way that people can help you add more data into, whether it's just on, does it need to be just the fact that a new setting is going to add much more information, or do you really need to go quite deep into this estimation of the overheads for it to work properly?
Yeah, so the Valley TB methodology had a real focus on collecting overheads accurately. And so adding in more data from that didn't really follow such a comprehensive methodology, I think would be less useful. But yeah. I mean, the main thing would be adding more countries. It would be amazing if like another country did a similar study using the Valley TB costing tool. So and then we could add to the data set. I mean, that would be the ideal. Yeah.
Nice. Thank you.
Thanks.
Thanks, Alvaro. Pete, I just saw you also added a suggestion in the chat. I don't know if you want to say that out loud.
I mean, it's just in case it's not being tried. I guess if you think, I was trying to think about within the context of a linear model how you would try to get a correction that had the right behavior. And I suppose if you had a variable that was, for example, particularly good as a single predictor and was positively correlated, then including a quadratic term for that variable would allow something that was smaller at the small end and higher at the high end than relative to the linear prediction. But
yeah, I think sometimes a quadratic term is included for scale in particular. And I think when I looked at this, that one didn't really help. But maybe I'll revisit it. I agree. I think that's probably the best sort of candidate for trying to improve the fit.
Thanks, Pete. Any questions from anybody else, particularly the many health economists who can ask more sensible questions than the rest of us?
Well, no, it's actually great to hear from people who are not health economists as well, because ultimately the unit costs get picked up and used by people who are not health economists. And I think making sure that the methods are transparent and people can use them well is like a big part of this.
Yeah, brilliant. I guess Mark, do you want to ask?
Yes, thanks, Alex, for the presentation. It was really interesting. Maybe one question, looking at your cost predictors. So I was just wondering whether you considered adding information on how the health system is organized, as a predictor of unit costs. For example, the way the health system can be organized with district health offices at provincial level, at regional level, at district level, etc., can potentially affect overheads, which can be big contributors. And I don't know, just quickly thinking about this, it might be information fairly accessible for a model. I was just wondering whether you had considered that.
Yeah, so the only problem with predictors that are at the country level is that we only have 5 countries. So pretty much, and we don't have a huge data set here either. So because fixed costs are the same across different visit types, even though we had observations of different activities at the same facility, we only have 115 total facilities. So for this model, it was 115 observations across 5 countries. And we're already including random effects at the country level. So if you try and put in also a fixed effects covariate at the country level, I think you're just trying to learn too much. You just don't really have enough information, unfortunately. So I did play around with dropping the random effects and instead including like country level effects like GDP or building price indexes at the country level. And overall, those models worked less well than just using country random effects. So basically, if there was more country data, we could add in some of these country level covariates, and maybe yours would be a candidate that I hadn't considered. But unfortunately, with only 5 countries, it's just not feasible.
Thanks. And actually, in terms of including, more data from more countries, how is this being planned with Capture? Or
no, Capture is just only about using secondary data. We don't have any funding to sort of do primary data collection or anything like that. But hopefully this work could maybe motivate people to think that it's worth investing in some extra country data collection, because that would definitely improve the models and make them more robust and more extrapolable.
Okay, thanks. But really interesting work. Thanks.
Yeah, thank you very much. Maybe just a last question, sort of trying to get my head around some of it. You were saying that this is obviously, not for all service types, and talking about how you might use the approach for what Alvaro was talking about, for example, with the infection tests. And I was thinking about other things like, active case finding campaigns or vaccinations or something where you probably don't have the overheads. And I was just wondering, what are the sort of, is there a next obvious place to take this? Maybe.
So this is only looking at services that are delivered in outpatient clinics. Yeah, so if it's happening in the community, it's not going to be, not going to be usable there. I mean, community-based services are actually a whole other kettle of fish, I would say, because they are much more variable across settings. And I actually don't think the econometric, like the statistical approach, is really useful there. I think there's just too much heterogeneity, basically, across community-based settings. We actually have another work package which is looking at predicting community-based costs, and the conclusion has basically been that you can't do it statistically. You would need to collect vast amounts of data to learn the kind of cost drivers there. So trying to break those down further in terms of production processes and compose them out of smaller costs that depend very much on your local setting is probably the most, or maybe the only feasible way of doing those.
Thank you. Any last questions, as I think we're pretty much out of time at the moment. All right. If not, thank you again, Alex. I think you can see lots of interest from the modeling community, and
thanks so much for the questions and suggestions. Really appreciate it.
Yeah, I imagine the app and the GitHub will be getting a lot of interest in the coming months as well. I think as people, I think that's really useful for us as well to have access to.
Great.
Thank you so much again, and thank you everyone for joining us. We do actually have a TB Max seminar planned for August, if anybody is around. It is looking at TPT in Brazil, I think, towards the end of August, if anybody is interested. But thank you so much again, Alex. And really, really nice work to see, and I look forward to seeing the publication when you do get that out as well.
Thanks so much for having me.
Cool. Thanks, everyone.
Bye.
Thank you.